Solving exponential and log functions. The first property that we're going to go over is something we've already touched on a little bit, but it's the property of equality for exponential functions. And what this is saying is if you have the same base on both sides, then you can set the exponents equal to each other. You've seen this when we were solving for logs. That would be yesterday's lesson. So an example, or a basic example of this, is if you have 4 to the power of x is equal to 4 to the power of 3. Because you have a 4 on both sides, you can set your exponents equal, and you end up with x equals 3. Let's take a look at these 4 examples. These are definitely more complex than the examples you saw in the note sheet yesterday. For number 1, we have 3 raised to the power of x plus 1 is equal to 81. So the first step would always be to isolate just the one single value on each side, meaning sometimes you might have to add or subtract some numbers. But in this case, we have one single value on each side, so we're all set with that. We're going to start by converting to the same base. So here's where you need to be good at breaking down your exponents. 3 to the power of x plus 1 we cannot simplify, but we can simplify 81 to 3 to the power of 4. And once you get to the point where you have the same base, in this case the base is 3, once you have the same base on each side, you can set your exponents equal. X plus 1 is equal to 4, and x is equal to, when you subtract 1 from both sides, x is equal to 3. You can substitute this back into the equation and check to make sure it comes out to be true. For number 2, start by checking to make sure you have one single term on each side. We do, so we're all set. We have 16 raised to the power of x plus 3, and that's equal to 4 raised to the power of 4x plus 7. So this one has a few different ways you can solve, because you could break 16 down to 2 to the 4th, or you could break it down to 4 squared. I'm going to use 4 squared because if I look on the right side, I already have a base of 4. However, if you choose to break it down using the base of 2, you are going to end up with the same answer as me. So starting with 16, I'm going to rewrite 16 as 4 squared. I already had an exponent of x plus 3, and this is equal to 4 raised to the power of 4x plus 7. Before I can simplify anything, I need to eliminate my double exponent by multiplying them together. I have 4 raised to the power of 2x plus 6 is equal to 4 raised to the power of 4x plus 7. Now that I have one base, or a common base, of 4, I can set those exponents equal to one another, and my solution will be found by 2x plus 6 is equal to 4x plus 7. In order to solve for x, I'm going to subtract 2x from both sides. 6 is equal to 2x plus 7. I'm going to subtract 7 from both sides. I end up with negative 1 is equal to 2x. Divide both sides by 2, and x is equal to negative 1/2. You can also check this answer. For number 3, here's one where we have to do a little bit of work before we can create common bases, because this side of the equal sign has multiple terms. We only want one term on each side. So I'm going to add 4 to both sides of this equation in order to eliminate my double set of terms on the left. This gives me 2 raised to the power of x plus 6, and this is equal to 32. Now I have one single term on each side. I can break down my values. 2 raised to the power of x plus 6 remains the same, but 32 is 2 to the 5th. I have a common base, set those exponents equal. X plus 6 equals 5, subtract 6 from both sides, x is equal to -1. And lastly, in this section number 4, we have to create one single term on each side. So I'm going to subtract 3. That gives me 27 is equal to 9 raised to the power of 2x minus 5. This is the first one where we have to simplify both sides. Simplifying both sides would give us 3 cubed is equal to 3 squared raised to the power of 2x minus 5. Eliminate your double exponents by multiplying them together. We have 3, when we distribute this, raised to the power of 4x minus 10. Same base, set those exponents equal. 3 is equal to 4x minus 10. Add 10 to both sides. 13 is equal to 4x. Divide both sides by 4. X is equal to 13 over 4. For the next example set, we're solving log equations by using the log properties in exponential functions. So we're using the log properties that we went over yesterday, but we're going to be solving them the same way that we already learned. So we learned this a couple of days ago. The log properties that I'm referring to in this example set is the product property. Product is when you pair addition and multiplication. The quotient property, which is when you pair subtraction and division. And the power property, which is when you eliminate your exponents by making them multipliers. So for number 1, we have log base 8 of x cubed, and that's equal to 12. I have that exponent where I can rewrite it as a multiplier. 3 times log base 8 of x is equal to 12. By doing that, I am now able to divide both sides by 3, and I eliminated that value right away. This gives me log base 8 of x is equal to 4. At this point, you solve it the same way that we've been doing these. So we started this a couple days ago, where you do the loop method and you convert to exponential form, and then you solve. This becomes 8 to the 4th is equal to x, and 8 to the 4th is 4,096. You just have to type that into your calculator. You don't have to do anything else with that number. So to add a couple notes in, you always want to isolate the expression, which might mean you need to use a property. And then after you do that, you need to convert to exponential form and you need to solve. Number 2, 6 plus 2 times log. This is log base 10. Recall that if you don't see a base, then it's automatically log base 10. 2 times log base 10 of 5x is equal to 18. Well, right here I can start by eliminating that value of 6. I subtract it from both sides. 2 times log base 10 of 5x is equal to 12. Then I can get rid of this value of 2 by dividing both sides by 2. Log base 10, I'll write that in there. Log base 10 of 5x is equal to 6. Now you can convert to exponential form. 10 to the power of 6 is equal to 5x. I need to isolate x, so I divide both sides by 5, and then I type this expression into my calculator. That means I'm typing 10 to the 6th divided by 5, and my solution will be 200,000. You should all double check that and make sure you get the same answer as me. The next property we're going over is the property of equality, but for log functions. And this property states that if you have a log on both sides of the equal sign, and within those logs, the log and the base is the same, then you know that the argument x is equal to y. That would be this value is equal to this value. You need to always check your solutions. This is important. You cannot have a negative value inside of the logarithm. Your solution could be negative, but when you substitute it back into the problem, it needs to simplify to a positive value. Meaning maybe your argument is x squared, and then the value of x is negative 4, but when you substitute that back in, x squared ends up being positive 16. Anyways, the first example, or the example I gave you in this section, shows that log base 2 of x is equal to log base 2 of 6. So you can see that the log and the base on both of these is log base 2. That means you can set x equal to 6 as your solution. Okay, sometimes you're going to have to condense one side in order to solve for these, but the first one is nice and simple as far as identifying that you have log base 5 of 4x minus 7, and this is equal to log base 5 of x plus 5. Because that log and base are the same on each side, you can set 4x minus 7 equal to x plus 5. Subtract x from both sides. 3x minus 7 is equal to 5. Add 7 to both sides. 3x is equal to 12. Divide both sides by 3. X is equal to 4. Now before you finalize this as your answer, you just need to substitute it back into your original expression and make sure both of your arguments come out to be positive. So if we check the first one, 4 times 4 minus 7, that's definitely a positive number. The second one right here, 4 plus 5, also a positive number. So this solution works. Oops, it is included. You just have to make sure you always check your answer. Number 2, log base 3 of x squared plus 3 is equal to log base 3 of 52. Because we have the same log and base on each side, we can set our equation up as x squared plus 3 is equal to 52. X squared is equal to 49. Take the square root of both sides. X is equal to positive or negative 7. Now before we finalize this, double check it in your original problem. If I substitute positive 7 into this expression, it comes out to a positive number. 7 squared is 49, plus 3 is 52. If I substitute negative 7 into that expression, I get negative 7 squared, which is still positive 49. So we are good. Both of these numbers work. They are both your solutions. Number 3, we have log base 4 of x is equal to log base 4 of 3 plus log base 4 of x minus 2. As you can see, you have the same log and base on all parts, or for all parts, but the right side of the equal sign, this needs to be condensed before you can solve. And because we have a addition sign, recall that addition is paired with multiplication, and that forms the product property. This is from yesterday's notes. Log base 4 of x is equal to log base 4. I need to multiply these arguments. 3 times x minus 2. I still have to multiply that expression together. So I have log base 4 of x is equal to log base 4 of 3x minus 6. At this point, we have the same log and base, which is log base 4 on each side. So we can set x equal to 3x minus 6. I'm going to subtract 3x from both sides. Negative 2x is equal to negative 6. Divide both sides by negative 2. And x is equal to 3. Make sure you check that in the original equation. Make sure it comes out to be true, which it does in all cases. This is your solution. And lastly, number 4. Number 4, we also have to condense. We have log base 6 of 4x minus log base 6 of 2 is equal to log base 6 of x plus 3. This is subtraction, which is paired with the quotient property. When I condense this, I have log base 6 of 4x divided by 2. The quotient property pairs subtraction with division. This is equal to log base 6 of x plus 3. I have the same log and base on each side, so I can set 4x over 2 equal to x plus 3. Four x over 2 will simplify to 2x. 2x is equal to x plus 3. Subtract x from both sides. We end up with x equals 3. And once again, just check your answer. Make sure all the arguments come out to be a positive value. You're checking it in the original equation. In this case, it does, so x equals 3 is your final answer. All right, so in this box, I'll just recap this really quick. It says solving exponential equations with different bases. Sometimes we are given exponential equations with different bases. In order to solve these equations, we must know logarithms and their properties. To solve exponential equations with different bases, you're going to use logs, and you're specifically going to use log base 10. It's the common log, it's the logarithm that's in your calculator. So if you look at this memo, it says if a to the power of x is equal to b to the power of y, you clearly can't solve for that. So if that's the case, then you can write in a log in front of each term. So it kind of appears like you're just writing it in. You're just putting it in front of each value. You originally had a to the power of x is equal to b to the power of y, and then you literally just wrote this in front of it. So that's what you're doing, but it's going to allow you to use your calculator to solve for the problem. If we look at an example, we have 4 to the power of x is equal to 13. We can't do anything with that, with what we know up to this point. So you're going to use log base 10, which is the common log. What I'm going to do is I'm going to write that in front. I'm going to write log of 4 to the power of x is equal to log of 13. Now I have to get it to a point where I can actually type it into my calculator. Of course, I can't type x into a calculator. So what I'm going to do is I'm going to recognize that x is an exponent. I can write this in front of the logarithm. I have x times log base 10 of 4 is equal to log base 10 of 13. Now in order to get x alone and to solve for the problem, I'm going to divide log base 4 by both sides. On the left, log base 4, it should be log base 10 of 4. But log base 10 of 4 will cancel, and x is equal to what you're now going to type into your calculator, log base 10 of 13 divided by log base 10 of 4. You can see off to the right our solution is 1.85. So x is approximately 1.85. You could check that in your problem. You could type in your calculator 4 raised to the power of 1.85 and make sure it comes out to approximately 13. Number 2, 3 to the power of x minus 4 plus 2 is equal to 10. Well, we're going to check to see if we can create a common base first. You always want to check to see if you can use a common base. So I'm going to subtract 2 from both sides, and I end up with 3 to the power of x minus 4 is equal to 8. Of course, you could break 8 down to 2 cubed, but that does not give you the same base on both sides. So the only thing I can do is I can use my common log. Same thing as before, let's take this exponent, we're going to write it as a coefficient. X minus 4 times log of 3 is equal to log of 8. I'm going to divide both sides by log of 3. And at this point, I have x minus 4 is equal to log base 10 of 8 divided by log base 10 of 3. So I do need to take care of this value of 4, whether I do it now or if I do it after, doesn't matter. I'm actually going to do it now just so I only have to use the calculator once, but either way. If you're adding 4, make sure you add it to the entire expression, not just the numerator or denominator. So we have log of 8 divided by log of 3, which in my calculator I will put parentheses around, and then plus 4. And you can see off to the right, my answer is approximately 5.89. Please complete the on your own section by yourselves. My answer key is posted on my website underneath the class notes. You can check that out to make sure you're on the right track. Please let me know if you have any questions.